Hey everyone, today we're on Unit 5, Lesson 5, Polynomial Inequalities. So this is the last lesson of our unit, and I hope you guys starting to make sense of things here. So we have, let's say we have the graph of the function f of x equals x cubed plus x squared minus 6x, which is pictured below. We want to factor f of x and use the factors to find the zeros of the function. So today I'm just going to kind of try to connect some of these things that we've been talking about over the past couple of days. If we want to factor this, when we look at x cubed plus x squared minus 6x, I see I have an x in each term. So I'm going to factor that out. And then break this up. I can factor two numbers multiplied to -6 combined to give me +1, x plus 3, x minus 2. And the zeros of this function, if we set each factor equal to 0, we get x equals 0, x equals -3, and x equals 2. Now I just want to go on my graph for a second. Do it in blue here. So I have -3, 0, and 2. So I just kind of wanted to point out how our zeros we found correspond to the graph that we're looking at. And now let's go down below and answer some of the questions that were being asked. Using the graph, identify the values for which each of the following equations or inequalities is true. F of x equals to 0, well, we're just physically taking the x-intercepts from our graph. X equals -3, x equals 0, x equals 2. And again, I want to just remember they came from our factors. Now we're seeing them as x-intercepts on the graph, so I'm hoping that finally is connecting with you guys. Now I'm going to take a look at my picture, and I'm going to identify where the graph of f of x is greater than 0. Remember, that means where the graph is above the x-axis, or in the positive. So if I go on my picture and I look for where the graph is above or positive, it's going to be there and there. If I want to describe those intervals now, we're not including 0 this time. We don't use 0, so we're going to use parentheses to describe these intervals. -3 to 0 and 2 to infinity. Now I wanted to describe the intervals where the graph is below, right? F of x less than 0 means my graph is below the x-axis. And if I go over to my picture and I just kind of highlight where it's below the x-axis, we see that that occurs. And again, we're going to look at our inequality sign very, very carefully. We're not including our zeros. So we have -infinity to -3 and 0 to 2. Now, when we look at the next two, I hate how the colors. Now I want to include my zeros. Okay, if I look at these next two inequalities, we're including the zeros each time. So when we look at our graph, we're going to now, when it's greater than or equal to, we're going to include these pieces. So I have brackets defining my endpoints of my intervals. But we know we never have a bracket on an infinity sign, so we leave that with its parenthesis. F of x less than or equal to 0. Now I'm looking below the x-axis, and again, including the x-intercept this time. Below the x-axis and including my x-intercepts. Okay, so we just want to kind of be able to differentiate between when our endpoints are included and when our endpoints are not. Now, we had sort of done that earlier in the year, but I kind of wanted to bring it back again, because now we're going to take a look at how we can do this algebraically. So we're going to, instead of always looking at a picture, we're just going to use algebra to do this. When we do it algebraically, we're going to take the same exact inequality. Okay, and I have the steps described here. We're going to completely factor the polynomial if it's not already factored. We did this above, so we kind of can cheat here. My factors are x plus 3 and x minus 2. And now we're just going to take, and we're going to take this and set this equal to 0. We're going to ignore the inequality sign for just 1 second, and we're going to find the zeros of this function, which again match what we found up above. Then we take and we put these zeros or x-intercepts on a number line, -3, 0, and 2. Make sure you put them in order, please. Now here's the hard part. Here's the part that's a little new to us. We want to choose a number, although we just did it with our absolute value, but now we're doing it with a polynomial. We're going to choose a number from each interval and determine the sign of each factor based on the chosen value. So we're basically, I call this test each interval. So we're going to plug a number and test it. And when we test it, we definitely want to use our factored form. We want to start learning how to do this. So we're going to use our factored form and test our interval. So if I pick a number that's less than -3, try -4, right? Don't go too crazy. To make something easy. If I plug it into each factor, I want to see what I get. When I plug -4 in, I get a negative factor. -4 plus 3 is also a negative number. I don't care about the value, just whether or not it's positive or negative. -4 minus 2 is also negative. If you multiply 3 negatives together, you're going to get a negative value, a negative y value. Numbers between -3 and 0. So I'll take -2. Again, we're plugging into the factored form. -2 plus 3 is positive. -2 minus 2 is negative. A negative times a positive times a negative will give me a positive interval. Pick a number between 0 and 2. I'll take 1. When I plug in 1, I get a positive factor. 1 plus 3 is positive. 1 minus 2 is negative. So all of my y values in that interval is negative. And pick a number bigger than 2, so let's say 3. Positive, 3 plus 3 is positive, 3 minus 2 is positive. Multiply 3 positives together and you get a positive value. When we're writing our solution set based on our number line, we're going to refer to the original inequality. Okay, so in this case, we're greater than or equal to 0 when we're identifying our solution set. So we want to, which means the solution will be the values that make the polynomial equal to 0 or positive. So strictly from our number line, then we're going to match it with our graph above, but we're not always going to be looking at the picture. So strictly from our number line, we want to identify, and I'll change my color so we could see it a little bit. Greater than or equal to means I'm taking the positive values. So I'm going to include, that's my solution set with my endpoints included. If they were not included, I would just put an open circle. Include. And if I identify this, I'm going to have, right, we're doing the positives, -3 to 0 and 2 to infinity. And let's just go see, compare it with what we got above. F of x greater than or equal to 0 matches here, and it matches our graph. Okay, so our positive interval means the graph is above. Ready? So now we're going to do it, even though the picture is included above, let's try to not refer to the picture and we'll match it up at the end. So we're going to consider the function -x times x plus 2 -x, I don't know what just happened there. but we just got rid of it. Negative x times x plus 2 times x minus 2 squared. Completely factor the given polynomial, provided that it's not already factored. Since this is in factored form, we're good to go. And I should have mentioned before, everything's got to be to one side and the 0 has to be on the other. Now we're going to set each factor equal to 0. So now, remember, what I'm going to do is get rid of my inequality sign for just a second and then go back to it at the end. So I have negative x equals to 0, x plus 2 equals 0, and this is x minus 2 squared. Remember from the other portions of this lesson, it just means that this factor occurs twice, but we really only see it once on our number line. Okay, and it means the graph is going to bounce. So when we're putting it on our number line, we have negative 2, 0, and I'm only going to put that on once. Okay, and we're going to see and talk about what happens. Now when we choose a number from each interval, okay, so we're going to test our intervals again. I might write my numbers in a different color. We're going to test negative 3. I'm going to test negative 1. I'm going to test 1. And I'm going to test 3. Remember, we're testing it in our factored form. We want to be real careful to use this nice factored form. This one's a tiny bit tricky because we have that negative x out front. Don't worry about it. Just kind of think in your head. Negative, negative 3. That's going to give me a positive number. Negative 3 plus 2 is also positive. And I don't care what I plug in to the last factor. If I square it, it's always going to be a positive number. I feel like I did something wrong because it doesn't match my picture. Oh, I know what I did wrong. It's right there. Stupid me. Let's go back. Negative, negative 3 is positive. Negative 3 plus 2 is negative. And then a positive. So this is going to be a negative interval. When I test negative 1, again, negative, negative 1 is positive. Negative 1 plus 2 is positive. Negative 1 minus 2 squared is going to also be positive. We don't care what number we get. When we square something, it's always positive. In the next section, when I plug in 1, now my term out front, my factor is negative, positive, positive. I'm back to a negative interval. And when I pick a number bigger than 2, negative, positive, positive, again, I see a negative interval. We'll connect this in just a second. Let's just refer to our original. I want to identify the places on the number line that are less than or equal to 0. So when I do this, I'll change my color so we could see it better. Less than or equal to means I'm picking the negatives. Closed circle because I include my endpoint. That's a solution. Closed circle, a solution, and we're going to continue on. So this means this whole section works. So when we describe our solution set, my solution set is going to be the values from negative infinity to negative 2, and from 0 to infinity. Now I've been noticing some of you, if there is sections, some of you have been breaking them up and writing them with parentheses. That is not correct. Some of you have been doing this. This is not correct because 2 is included. So we don't have to do that. We can include that whole section. It's a continuous function, so you don't have to worry about any breaks in your intervals. So there's our answer there. Now let's just connect what we got. Refer back to the graph of h of x picture below. Explain how your sign analysis in the process below is confirmed by the graph. Well, we wanted to look for where it's less than or equal to 0. If I look on my graph, I've identified those sections. So negative signs correspond to the graph below the axis, and positive signs on our number line is where the graph is above. Do we need to be looking at the picture? No, we can trust, if we get good at number line testing, we can trust our number line and we don't have to see that picture. How would your solution to the above inequality be different had the original inequality been greater than or equal to? In this case, we would have picked the positive from our number line. So let's just go back and do that now, right from our number line. So if I was doing greater than or equal to, my solution set would have been -2 to 0. How about if it was just greater than? Then we don't include our endpoints, so we're going to have parentheses there. So, abbreviated version, when we're solving inequalities, we want to get the zeros, put them on a number line, test the intervals, and then pick the appropriate solutions based on the inequality sign. So if it's greater than or equal to, we're looking for pluses. If it's less than or equal to, we're looking for the minuses. Now let's look at a different situation here. Okay. Consider the polynomial x cubed minus 9x is greater than or equal to 3. What do you notice about this polynomial as opposed to the previous examples? Now there's two things that are different here. First of all, it's not in the proper form. Okay. In order to solve this, we have to get everything to one side. Okay, so whenever we're solving a polynomial inequality, we want to remember that. Okay, so get everything to one side. Now, when I look at this, when I go to find, to move forward with this, the big thing here is you can't factor this guy. So at this point in time, we're going to talk about what happens when we can't factor. Okay. If I look here, I can't, it's not a quadratic. There's no factor by grouping. Okay. So when we can't factor it by algebraic means, we're going to have to, we're going to have to rely on the graphing calculator. So we're going to talk about how we can do that. Arrange the inequality so all monomials, okay, so we already did that. Now what we want to do is we want to take this and plug this into our graphing calculator. Okay, so we're going to get up to our graphing calculator here. I want to clear out what's there, and I'm going to enter my new polynomial. Don't worry about the inequality sign. We're just entering in x cubed minus 9 x cubed minus 9x minus 3. I have a habit of making mistakes. I'm going to double check that before I graph it. So I'm just looking at this picture. When you look at it, I have an x-intercept. It looks like it's just a little bit before -3. It's not going to be a very nice number. I have another x-intercept here, and I have another one a little bit greater than 3. So we want to take that and we want to kind of transpose it onto our little grid there. So my x-intercept was about there, another one about there, and another one about there. Notice they're not nice numbers. So we wouldn't be able to even use synthetic division on this one. And then to the best of your ability, just kind of connect them. It's just a sketch. Hopefully by now you realize that your x-intercepts, right, are what's important on your graph. Now, the next thing we're going to do here is, since these are not nice numbers, and since we can't get them using algebra, we're going to have to physically just get them using our calculator. So the method of doing that is we're going to use the second trace function. So we're going to use the second trace 0. So we choose that option on our calculator. And now I'm going to go through and I'm going to kind of identify each of my zeros. I'm going to go all the way back. I'm just using my little cursor, my little arrow buttons, and I'm moving see my little X guy there? So do you see how the calculator's asking you for left bound? You want to move your little Xy guy there to the left side of this x-intercept. I'm going to move it down. I want to be further. Hit enter. Now the calculator is asking for the right bound. So I'm going to press my arrow key just to the right of it, hit enter. And now the calculator identifies the zeros as negative 2.721. I got a different one when I did it on my graphing calculator. I'm going to do that again. Second trace 0. I might have hit something a little off. Enter. Enter. Okay. So your zeros are negative 2.722. Not going to lie, I'm not in love with this graphing calculator on the iPad. I prefer you would do it on your old-fashioned one. So I'm going to move on now. I've identified that 1, 0. So I'm going to move on. Second trace 0. Now I want to focus on the middle. Left bound, right bound. Hit enter one more time. This is not right. Left bound, right bound. Hold on 1 second. I just want to plug in the number. X equals negative 0.338. Yeah. So the numbers I'm getting from the iPad calculator are different from the numbers that I'm getting from my old-fashioned calculator. So I'm going to go with these. So we see on our calculator what they are. But from my old calculator, I got, and I'll write the steps here. We use second trace. You choose the 0 option. We do left bound, hit enter. Right bound, hit enter. And then the calculator asks you to guess. This is in the old-fashioned one. Hit enter one more time, and it gives you the actual x-intercept. And when I did that, I'm going to get my old one back from the calculator for a second. I've noticed some discrepancies on the iPad calculator, so enter. Negative 2.817. X equals negative 2.817. That would be that x-intercept. I got negative 0.338. That would be that x-intercept. And then I got 3.155. And that's that guy there. So those are our x-intercepts. Now, graphically, what does the solution to that inequality represent? Like, how would we choose our solution now? If we want to identify where this graph is greater than or equal to 0, all we have to do is look at the positive intervals. Okay, so you really don't, you could set up a number line if you want, but we really want to just identify. So I have negative 2.817 to negative 0.338. My endpoints are included because of my inequality sign. And then I'm going to start at 3.155 and go to infinity. Okay, so we're identifying the above the x-axis. How would your solution set be different if this was our original inequality? Remember, bring everything to one side, except now when we're graphically identifying our solution set, we're going to pick where the graph is below. Okay, and we have to be real careful because we're not including. So our graph would be, our solution set would be negative infinity to negative 2.817, not included, and negative 0.338 to 3.155, again, not included. Okay, so we'll make a note of that. And before we leave today, that was the last example. I want to go back up. I'm sorry, I should have mentioned this. When we get these two, right, we talked about, let's talk about these, the multiplicity of 2. Notice we get 2 negative intervals. Okay. That means our graph, if you, on the graph of your function, when you're looking at the graph is staying negative because it's bouncing at that x-intercept. I should have made that connection before. I'm sorry. Okay, so I hope you've enjoyed some of the things we've talked about throughout this unit. And we will be back together soon. Thank you.